first thing we do, try to plug in 5, and when you do that, you get 0 over 0. So what you're thinking is, God, I got to do more work. Darn it. Well, let's do some more work. If you plug in 5 0, that means x minus 5 has to factor out of that top somehow. Okay, so we got to be able to get x minus 5 out of this numerator. The problem is, we've got these square roots, and you can't just take them away. You can't just square the top and get rid of them or anything like that. The only thing you're allowed to do to a fraction is multiply the numerator and the denominator by the same thing. So what we're going to do is multiply the numerator and the denominator by the one thing that will cancel out these square roots, and that is the conjugate of the numerator. So I'm going to multiply the numerator and the denominator by the same thing. So really I'm just multiplying by 1, and when you do that, what we get is the limit as x goes to 5 of x minus 5, because multiplying conjugates, if you FOIL these out, you get x minus 5, over x minus 5. I'm not going to FOIL out the denominator. I'm just going to let it be. Because remember, my goal was to get that x minus 5 to cancel. And now that's going to happen. The x minus 5's cancel out. And if it cancels out, that really means there was a hole in the graph. So the hole at 5 now is not affecting what the limit equals, because the graph of our original function looks exactly like the graph of this function, which is much, even though it's still got the square roots, it's much nicer because this function is continuous everywhere. So to evaluate this limit, I can just plug in 5, and I get 1 over root 5 plus root 5. And that's just 1 over 2 root 5. So there's our answer.